today we're going to talk through properties of bonds, and then we're going to go into the basics of naming and writing formulas for ionic compounds. So you will want your guided note sheet and your periodic table out. So firstly, just to jog your memory, and you don't need to write this down because your periodic table is probably already colored in, but we need to remember what elements are metals and what elements are nonmetals and metalloids. So as a reminder, your metals are around here on the periodic table. And then your metalloids are this green stair step, and then the nonmetals are located here on the periodic table. The majority of your periodic table, as I said previously, is are metals. So keep that in mind as we keep moving along. Now, properties of ionic bonds. They're always a metal and a nonmetal. So a good example of that, I'm just going to get my little writing tool here, is NaCl, sodium chloride, or table salt. You got your metal in sodium and your nonmetal in chlorine. They always have a crystal lattice shape, okay? So that means that their positive and negative ions are arranged in a little sort of cubic shape or diamond, just some sort of organized 3D shape that gives the bulk, so the things that we can see, the bulk sizes of the material, a particular shape. They conduct electricity when in solution or liquid. So I would say make sure that you write solution or liquid. L is acceptable. They have high melting points. So think about it. You cannot melt salt on a stove. Okay, you need something like a blast furnace or a forge to melt it. And then they form what we call compounds. Okay, don't ever refer to an ionic compound as having molecules. They do not form it. Covalent bonds. They are metals with other, or I guess nonmetals with other nonmetals, or a nonmetal and a metalloid. So water is a good example of a covalent compound. They do not conduct electricity. So pure water does not conduct electricity. Sugar does not conduct electricity. Good examples. They have low melting points. Okay, think about it. Water is liquid at room temperature. So it has a fairly low melting point as compared to ionic bonds. And they form what are called molecules. So think about that common representation of water. You've got oxygen with two hydrogens hanging off of it like that. That would be an example of a molecule. Okay, now we're going to go to our next slide, into ionic bonds, our next topic. Now, ions, if you remember, are charged atoms based on the gain or the loss of an electron or multiple electrons. Negative ions happen because they gain an electron, okay? We call those anions. Now, positive ions happen because they lose an electron. So cations are positive ions. There's my bad joke for today. Cations are positive. Okay, so you can see that in this diagram below here. So we have our metal, which is sodium, and our nonmetal, which is chlorine. Sodium has this extra electron that it doesn't really want anything to do with, because if it got rid of that electron, it would have a full valence shell. So it transfers this electron over to chlorine. And what results is we have a sodium cation because it lost one electron. It's now positively charged. And then we have a chlorine anion, which is negatively charged because it gained that electron from sodium. So that actually ends up being quite handy to see. Now, ionic bonds happen when a metal donates its electrons to a nonmetal. So a good thing to remember is that metals, I'm going to write this out for you here, just with my text. Metals are this is just not wanting to write. Well, we'll just erase all of that. And we'll try this again. Metals are electron donors. Pretend that I know how to type. Oh, this is just really not wanting to. And well, nonmetals are also electron acceptors. So that would be something to remember. We like to include that on quizzes or tests. So you can see here that lithium is donating its electron to fluorine, which accepts the electron. Metal, electron donor. Non-metal, electron acceptor. I would like you, at this moment, to pause your video and get out your periodic table and write down the known charges that are here. You should notice that alkali metals have a +1 charge. Alkaline earth have +2 charges. We are going to skip over transition metals because they do not have they have multiple charges, so we're going to deal with that tomorrow. Silver always has a +1, zinc and cadmium always have a +2, and aluminum always has a +3. I would not concern yourself with gallium because sometimes it has other charges rather than +3. Now, nitrogen and phosphorus have a -3 charge. Oxygen's column -2, fluorine's column -1, and the noble gases are 0. If carbon were to be in here, it would be right here, and it would have a -4. It just follows the trend. Rarely do we use carbon, but I believe it does show up on your homework, so I wanted to make sure that that gets included. Now we're going to go on to the next slide. So, we need to write down the charge of each one of these. So, you should notice, finding sodium, it is in the alkali metal, so it should have a +1 charge. Chlorine has a -1 charge. We can just write the plus and minus without the ones because chemists are lazy and we don't write ones. Now, barium is with the alkaline earth metals, so we have a +2 charge. Nitrogen, that's in that column with the -3s. Sulfur, that's in -2. Krypton, no charge, right? Because that is a noble gas. And calcium, it's in the same group as barium, so it's going to have a +2 charge. Okay, get yourself familiar with checking through the charges on the periodic table, looking at the periodic table to determine your charges, because we're going to need that for formula writing, which is what we're going to go into next. Okay, writing formulas. Whole goal, which you should have seen in your POGL yesterday, is that we want our total charges to equal 0. We will write the formula in such a way so our total charges do equal 0. So for example, we here have a +1 with potassium, a -1 with bromine. And so to write it, we would have KBr. Now, how about for magnesium and chlorine? Magnesium has a +2 charge as seen on your periodic table that you just labeled. Chlorine has a -1 charge. So to cancel out that +2 charge, we actually need 2 chlorines. If we do that, we would want to write a formula. We always put the metal first, so we have Mg, and then we have Cl with a subscript 2. So make sure you write that small and you kind of knock it down below the line a little bit. Formatting is important in chemistry. It makes sure that we are being clear about what we're talking about. So make sure you pay attention to capitalization and pay attention to your formatting. Formula for CaF. Once again, Ca is in the same group as magnesium, and fluorine is also a -1. So calcium plus 2, fluorine -1, we need 2 fluorines to cancel out that 1 calcium. We have CaF with a subscript 2. How about aluminum and oxygen? Aluminum has a +3 charge. Oxygen has a -2 charge. Their common multiple is 6. So we need 2 aluminums and 3 oxygens to make that work. Now, if you're somebody who's not super great with math, I'm going to show you a little trick that you can use. I'm actually going to roll this back. Okay, so I will show you. We have aluminum is always a +3 charge. Oxygen is always a -2, and I apologize for my handwriting because I am doing this with a mouse, not with a tablet. So you are going to circle the charge, the numbers of the charges. Don't bother bringing the charges down. Then we're going to crisscross our charges. And then we are going to write our formula, which is Al subscript 2 O subscript 3. That switcheroo works great for anything that has unlike charges. Okay, now we're going to just write some formulas. So sodium and bromine. This has got a +1 charge for sodium. Bromine has a -1 charge. So its formula should be Na, B, R. Fantastic. We're going to do the same thing with magnesium and nitrogen, calcium and sulfur, calcium and chlorine, and aluminum and fluorine. Okay, take some time to do that yourself. You can pause this. I am going to go through the answers in just a second here. Okay, you should get that magnesium has a +2 charge and nitrogen has a -3 charge. So if you do the switcheroo, you should get Mg subscript 3 and 2. Calcium and sulfur. Calcium has a +2. Sulfur has a -2, so we just need 1 of each. Chlorine has a -1. We already established calcium has a +2, so we need 2 chlorines. Aluminum is a +3, as discussed in the previous slide. Fluorine is a -1, so we need 3 fluorines to cancel out that +3 for aluminum. Okay, next slide. Try these on your own. Pause the video right now, and I will pop the answers up in 3, 2, 1. Check that you got it correct. Now we're going to go on to naming. Now the way to name this, what you're going to do, you're going to name the metal. Then you're going to name the nonmetal, cross the ending off the nonmetal, and add IDE. So an example of that. We have NaCl, table salt, our favorite ionic compound. We have sodium plus chlorine. We're going to cross off the ending of chlorine and instead put in IDE, so sodium chloride. That IDE ending indicates to us that the nonmetal is bonded to something. So now we're going to name each compound. Okay, an example. Jeepers, think I would be able to grab the right thing. Sodium, cross out IDE, bromide. Sodium bromide. This, magnesium plus nitrogen. We have magnesium, drop the ending, IDE, nitride. Same thing, calcium plus sulfur should be calcium sulfide. And so on. So I'm going to pop the answers to the examples up here. We've got sodium bromide, magnesium nitride, calcium sulfide, calcium chloride, and aluminum fluoride. Now I'm going to go on to the next slide. I would pause this video. I am going to put the answers up on display in 3, 2, 1. We have rubidium sulfide, cesium phosphide, lithium fluoride, potassium iodide, and barium oxide. My rule of thumb for figuring out where to cut things off is just to say it out loud. Okay, for example, oxygen is a weird one. Where do you cut it off? Well, oxide and oxyide sounds weird. Oxide rolls off the tongue. Sounds nicer. Same thing with phosphoride. Phosphoride is kind of a mouthful, but phosphide rolls off the tongue more easily. So that would be how you figure that out. Okay. Your assignment for today is that worksheet that I have left with the sub. So please make sure you grab that. Do it to the best of your ability. Check your work with the key. Do not copy off the key. And we will make sure that you understand this tomorrow before we go into writing formulas and naming with transition metals. Have a wonderful day. Thank you so much for listening.